Create unit tests using 3TG in VS Code. We will use a TypeScript project that exports a function named mathop, and we want to create tests for it. The mathop function expects two numerical parameters called a and b, and returns a number based on them. Let's use the 3TG VSCode extension to create all default tests for mathop. "3TG has created 81 tests for us, and it needed only around 1 second to do that. Now let's see which values it used.
Most likely, you did not think to test for infinity or not number values. We already have some tests for this function.
Let's use these test values with 3TG. For that, we need to create a configuration file. "3TG has created a complete configuration file for us with example values. However, we don't need the generated content. Let's remove it and add only what we need. We only need rules and test values specifically for the number parameters. Let's replace the test values with the ones in the existing test file. Let's now generate tests with these values. We will disable all default rules using the no default test rule setting. And since we want to overwrite the existing test file, we will also use the overwrite test setting. Now we have only tests using our custom values. What's missing are the expected results. We still have 36 tests generated, and it's still difficult to get a clear overview of them. Let's create a functional requirements file for better clarity. But first, let's disable the no default test rules setting. We will save it for better formatting. We are again in the same situation as when we started. All default rules are present in this functional requirements file. Let's use the utils configuration file when generating this functional requirements file. To do that, we need to copy utils.3tg.json as utils.md.3tg.json, and then generate the functional requirements file again. We need to re-enable the no default test rules setting so that we have only our test values in the functional requirements file. Now we have a functional requirements file containing only our test values.
And we can see all input parameters on one screen, and we only need to define the expected values.
It took me less than 2 minutes to define all 36 expected values and replace the test value placeholders with their actual values using VSCode's search and replace feature. Let's create the configuration file based on this functional requirements file so we can generate the tests again. Let's compare it with the original configuration file. The new configuration file contains more settings than the old one. As you can see, there are no expected values defined, hence the errors. Let's generate the tests again. Now our tests also have the expected values set. The order of the generated tests is not the same as in our functional requirements file, but this is normal. Let's run the tests and check if all of them pass. Both test files pass and both test the same function, mathop. Let's refactor the function and see if the tests still pass. We are running the tests again. Our tests defined with 3TG are failing, as expected, but our manual tests are still passing. In around 5 minutes, we were able to define relevant tests, even using a subset of meaningful values. As you can see, we have 9 times more tests, and the time needed by Jest to run them is only slightly higher than running the original 4 tests. But the benefit is much greater. What if we want to change the tests to use values suggested by 3TG rather than the ones from our manual tests? We will write tests for MathOp using only the following parameter values: 0, 2, not number, and the 2 infinity values. We will recreate the functional requirements from this configuration. We will now add the expected values. Let's see if our expectations are confirmed by the tests. We will generate the configuration from the functional requirements file, recreate the tests, and run them. We have 2 failing tests. Let's run Jest and allow it to display all errors. The failing tests occur when adding positive and negative infinity. Let's correct the expected results in the functional requirements file and regenerate the tests. All tests are running as expected. Now we have both relevant tests and a markdown file that documents how our MathOp function should work. Developers can also add additional information as long as they do not break the format expected by 3TG. If you found this helpful and you're leading a development team which want to boost code quality and test coverage without slowing developers down, head over to 3tg.dev and get your licenses today. 3TG is built for developers and teams who want to write better, faster, and smarter tests. And for companies that care about reliable code, fast onboarding, and scalable test generation. Purchase the right licenses for your team at 3tg.dev. Also check the Coding Creed Technologies manifesto at codingcreed.tech. You can contact us at any time by email at support@codingcreed.tech. Don't forget to like, subscribe, and leave a comment. We'd love to hear from you.